If you're struggling to convert between Newman projections and traditional wedge dash notation, I have a few tricks for you. Using my method, the carbon in the front of the Newman projection is always going to be carbon number 1, and the carbon in the back will be carbon number 2. Notice in the Newman projection, we have a few substituents that are pointed in the up direction, and we also have a few substituents that are pointed in the down direction. We also have substituents that are on the left-hand side and the right-hand side of the Newman projection. The substituents that are on the left-hand side are going to end up on dashed bonds. The substituents that are over on the right-hand side will end up on wedge bonds. And the way that I remembered that when I was a student is that dash comes before wedge alphabetically, and we go from dash to wedge if we go from left to right on the Newman projection. We also have two substituents that are in the center of the Newman projection. They will be not on dashed bonds, not on wedge bonds. They're just going to be on straight line bonds. Begin by drawing carbon number 1 on the left, carbon number 2 on the right. Carbon number 1 always has to be on the left and always has to be on the front of the Newman projection. Our carbon number 1 has a straight bond straight up to hydrogen. We're going to match that on the line dash structure. Carbon number 1 has a fluorine that is pointed in the down direction, and it's on the left-hand side, so it's on a dash. So we're going to draw a down dash fluorine. Carbon number 1 also has this down wedge methyl group. So we're going to draw a wedge in the downward direction, and that's a methyl group. Carbon number 2 in the back has a straight down OH group. So we'll put that right there. And carbon number 2 has an up dashed chlorine. So just draw a dash pointing up. That's your chlorine. And then we have an up wedged bromine. Draw your wedge sticking up. Put the bromine on it, and there you go. Now, if you're wondering if this method works if the Newman projection is in a different configuration, absolutely. Here's a Newman projection that is just basically kind of in the upside down orientation, and you can pause and see that this method still does work perfectly. What about if your Newman projection is in an eclipsed conformation? It also still works. You can pause here and look at it as well. Now, if you are being asked to convert the line dash structure into a Newman projection, that does get a little bit trickier. I want to remind you that carbon number 1 is always on the left, and carbon number 1 is always in the front of the Newman projection using my method. We also want to remind ourselves that our dashed bonds will be on the left and our wedged bonds will be on the right. On carbon number 1, we have this straight up chlorine, so we'll fill that in. We have a pointing down on a wedge hydrogen, and we have a pointing down on a dash bromine, like that. And then on carbon number 2, we have a straight down methyl group. We have a pointing up on the dash OH group. And we have a pointing up on the wedge fluorine. Now this is tricky, but I know you can do it. If you have any questions, just pop them in the comments and I'm happy to answer.